you all on qualifying IOQM. Your incredible journey to Maths Olympiad has just begun. And I suggest you that you take more pride in enjoying the journey, indulge yourself in lots of sightseeing. Destination can wait for now. And a couple of things about the session. It is actually a 90-minute session, as you know, and primarily I have designed it around some problems. And through these problems, I hope to share problem-solving insights that I gained both my time as a student participant first at INMOTC and later as a faculty on INMOTC. So let me share my screen with you all and turn to the problems. Can at least one person see the screen?
Yes, sir.
Okay, thanks. You are my best case for induction, easy induction that everyone can see the screen.
Yeah.
Okay, so I have shared the assignment, but let me just, it is primarily algebra. And so let me just show you, because some of you might not have got from HBCSE. They will share you in due time, maybe. So actually, I am guided by the philosophy that to do well at Olympiad or any maths contest, you need to be armed, not with so much abstruse technique, rather very simple techniques, but admittedly combined in very, very clever and ingenious ways. So these examples all illustrate that. As far as inequalities are concerned, I will be using Cauchy-Schwarz and AMGM, versatile, because they really sail you through in almost all situations. And other cases like functional equations also, I will be sharing some insights into how you choose your variables like x, y, z there when plugging the values and to get something more out of that. Those of you who are new to the subject, they would do well to learn inequalities and functional equation both from BJB book. That's really wonderful. Especially I'm fond of the functional equation book. It's a slim book, but it has got a lot of motivation. You could get problem these days anywhere. Like there is plenty of problems. So in fact, yours is a age in which you are spoiled for the choice. You have got lots of problems, but then you need a book which really tells you theory by some motivating examples, so that it stays with you. You know exactly why it is that you are doing what you are doing. So that should be your motto. Okay, so let me see that. There is a small typo in the first problem, a plus b plus c plus d equal to 4. So you can correct that 4, and other thing is correct. Some of you might have got also, but then because time is not such that I will allow each of you to share a solution, if you really get some good solutions, which is different from mine, then you can write me on my email. I can share with all of you then later. So let me now start. So A over.
Sir, if possible, can you please share the link of the PDF on the chat so that we all can see it?
I don't know. It might waste much of time, but I think I will write anyway. I have to write the problem, correct? And I will share it later on, right? And I'm sure that HBCSE will share with you, but still I'm writing the problem, because anyway to solve it I have to write it first. So A over A to the, otherwise it will waste our time that going over those things. B over B cube plus 8. I'm writing the question. I have to write. So see, A, B, C, D are positive real numbers, and A plus B plus C plus D equals 4. A over A cube plus 8, B over B cube plus 8, C over C cube plus 8, and D over D cube plus 8 is less than or equal to, let me check what it was. So you can see it here. It is less than or equal to 4 over 9. 4 is the small typo, so you can make it 4. Less than or equal to 4 over 9. When you see something like that, then start your journey from AMGM and then proceed to Cauchy-Schwarz other thing. Don't start anyway from constructing some kind of function that, okay, this is, let's convert to linear function or do something else. So first thing I will say that a cube plus 8 is there now. So may I break up it like a cube plus 1 in the hopes of making things linear and rational. And so I can write this AMGM that 3 times cube root of a cube. This choice of 1 is well motivated, 2 ones, not 3 or 4, because I know that the original equality holds for a equal to 1, b equal to 1, and all those numbers. So it's good that I have to honor that from the beginning. Otherwise, you would get a wrong bound, even if your solution is in the correct direction. Now, with this, I get a cube plus 2 greater than or equal to 3 times a. Everything is positive, so I can afford that. Anyway, cube root I don't care about, but a. So now I have to write like this way, that this is a over a cube plus 8. So I play with this term. This is less than or equal to a over, and this is 3a plus 6. So that is a over 3 times a plus 2. Once I know how to deal with this term, other terms follow suit, and I can write 1 over 3 and times sigma a over a plus 2. That gives me a over a plus 2 plus b over b plus 2. It's sometimes better to write in full. It gives you a feeling. Sigma somehow hides. So this is less than or equal to 4 over 3. This one. Now, again, a over a plus 2, I can write in terms of a plus 2 minus 2 by a plus 2. It is better because if you have got anytime if you get lambda a plus mu b or lambda a plus mu, anytime if you get lambda a plus mu and over say lambda 1 a plus mu 1, it is good that you write it as some constant a, some constant alpha and plus beta and times a upon lambda 1 a plus mu 1. That is better because you just, this is not a, just constant. So alpha plus b times this one. So it is better to write in terms of constant because you can deal with it. So I write a in terms of a plus 2 and 3 more such terms less than or equal to 4 over 9. That 4 over 3. That gives you 4 because a plus 2 over 2, 4 and minus 2 and sigma 1 over a plus 2. That is less than or equal to 4 over 3. So sign changes and this 2 cancels. I can write 2 minus sigma 1 over a plus 2 less than or equal to 2 over 3. That gives again 4 over 3. But this time you get 1 over a plus 2 plus 1 over b plus 2 plus 1 over c plus 2 plus 1 over d plus 2 less than, greater than or equal to 4 over 3. This is, we have reduced it to this form. So this has advantage. See, so if someone wanted to use Cauchy Schwarz in T2's form, those of you who do not know or may have forgotten, T2's form is this, that you have got p square over x, q square over y, r square over g, and many things you can write, is greater than or equal to p plus q plus r whole square divided by x plus y plus g. You need x, y, z to be positive, strictly positive, and p, q, r you can afford to be real. Because while proving this goes this side and you need that thing. Now, this was not suitable for because it was less than or equal to. So I turn it, after this also I turn it and I got greater than or equal to. From here I can finish in 2 ways. So one way is directly we can apply T2's inequality and one can write that if this is p, I can write p greater than or equal to 1 plus 1 plus 1 plus 1, 4 ones whole squared, and add up all the denominators. That nicely gives you a plus b plus c plus d plus 8. And so that equals, this is 16 and over constraint is 4. So 4 plus 8, 12. And that gives you 4 over 3 that you got. But I would prefer this, of course, in terms of writing this one, much elementary. Cauchy Schwarz in T2 form is an overkill for this. Yeah, of course, equivalent. So somebody can write this also. I would love this much more. Somebody can write just a plus 2 plus b plus 2 plus c plus 2 plus d plus 2. So he has created these 4 numbers and denominators 1 over a plus 2, 1 over b plus 2, and 1 over d plus 2, and greater than or equal to 4 squared. Here you are using a1 plus a2 plus an, the famous one that you learn at AMHM, 1 by a1 plus a2 plus an greater than or equal to n squared. Of course, you can derive it using Cauchy Schwarz also, but I would say appeal to elementary things. So it's like this kind of thing. Actually, it is these kind of habits when you see a problem, that how much more elementary my proof can be, that saves the day for you. It's not that you start your journey from upwards. Don't think of suddenly Karmata and Jensen's and all those things, big names. Don't Muirhead. So basically, try your hierarchy, like first simple non-negativity squares, non-negative. Then you go to AMGM. Then you go to Cauchy-Schwarz. If they don't yield anything, then of course you can think of some high-powered stuff. But before that, please hone your skills on these kind of things. Don't unnecessarily underestimate the importance of simple and clever things. They really save the day. Okay, any question on this one?
Can we use Angel's form directly in paper?
Yeah, of course you can. In the last step?
Yeah, like without saying like.
Yeah, in the last step you can use. See, I don't think that you need to write name, but at least even if you write the statement that I'm using this result, that's fine enough. I just named it because people normally know it by names, but you can just cite it. So there is nothing like this one. AMG including, of course, is very basic. Otherwise, you need not write Angel form or T2's form or what form. Okay, people may contest their authorship also, some of you at least. Okay, but then you can just write the statement that I'm applying this one, or you can state it as a lemma if you are not sure that what name to give. State it just a simple lemma. These are simple things, so need not be given proof also. You can just state, for example, these things, and simple you can finish it off.
Okay. We can use that in the above step only. This
yeah,
step.
Here, P.
Sir, we can. I thought what you have done in the final steps, we could have done that there.
Yeah,
also.
correct. So that I did here. I did two ways. First is this one. This is only Cauchy-Schwarz in 2T's form. T2's lemma. I'm calling this one that I refer to here. Dear, this one, the first line. And then I also told that you can also call it just AMHM inequality case, like A1 plus A2 plus AN, and 1 over A1 plus 1 over A2, AN, all this multiplied greater than or equal to N squared. So that was elementary, but both are of course equivalent. It's your wish, however you want to use. Okay, let me go to number 2. I'll first show you. And of course I have to write also.
Sir, since these were not like homogeneous, should we try for homogenization?
No, that's why I say that first don't think of very creative thing that A equal to X by Y, B equal to Y by G, or first of all homogenize, make 8 something sounding cube. Don't do these things. First, always start with non-negativity, then AMGM inequality, then Cauchy-Schwarz. Then up your game. It is a very sincere advice to all of you, both because I had my good time as a contestant and as an INMOTC student also, and the faculty also. Year after year, I see that people are actually going mad over many techniques. But then it's all like, first of all, you master the simple techniques. Simple techniques means that some powerful technique, versatile techniques, and try to see why people are applying. There is a method in madness. So you will get to know. And of course, experience is the best guide. Okay, so let us see number 2. This problem has came in many different forms. Those of you all of you can look at my lecture in batch 4. In batch 4, I did a problem sheet which is similar to it. Means that problems are not same. 1 or 2 may be common, but mostly they reflect the same thinking. So you can have a good practice. Like number 1 there is little trickier than the one here. Okay, but 2 is trickier than this one, and I have selected them because they all came in some national contest. So of course you know that, okay, these are the things that people are being asked all over the world. So let's do this one. This was asked in Singapore also, and later Romania also, this kind of questions. So I have written in general form, 0 less than A less than B. Here, what's the catch? So you have to find the greatest value of, let me write the expression for xyg, and over I have my copy, xyg over A plus X times X plus Y, Y plus G, G plus B. Let's call it P. And they have given 0 less than A less than B, means things are all positive and then B are not equal. And you want A less than X less than Y less than G less than B, for which P attains its greatest value. So you are supposed to find those A, B, this X, Y, and G such that expression is maximum. Now, suppose someone does like this. Someone does his first attempt or her first attempt like this, that they quickly notice that they can write a plus x 2 times the square root of x. They can write x plus y 2 times the square root of xy. They can write y plus g 2 times yz, and they can write z plus b twice of zb. This they can write. And if they write this and multiply all of them, let's call this denominator d and this is numerator, for instance. So I get d greater than or equal to 16, which I don't care much, is square root of ab, and then I get square root of x y z. So it's x square y square g square, and so I get 16 root ab and x y g. This I get. Of
Sir,
course, things are all positive. Yeah.
Okay.
Yes.
Sir.
You want to say something?
Nothing.
Okay, I'm coming to it. Maybe you have something in mind. I know. Trust me, I know your mind. Okay, so 16 root AB. Now, somebody can argue that this is this one. So somebody can argue that P is less than or equal to, because sign will turn, it is denominator. XYG has gone for good. You wanted it to go 16 root AB and XYG. And maybe you can cancel and you can claim that this is the desired maximum value, something like that. But that is wrong. So those who are doing first time, they will think that nothing wrong here. But the part is that you are using AMGM or any inequality, you are using it 4 times. So at each stage, equality must be honored. Equality must be honored. Otherwise, it is a strict inequality. So no use. Equality is not attained. See, for here, if you want at this stage equality to be honored, in the first one, you require A equals X. Similarly, you require X equals Y. You require y equals g, you require g equals b. So by this chain, you require a equal b, but sadly, a is given not to be b because a and b are like not equal, a less than b. So in fact, equality does not hold, and so this application is incorrect. In fact, everywhere you have got a strict inequality, and so equality cannot hold, or at least not simultaneously. You can force 1 to places, but not all places, and so this is not the maximum value. So whenever you are asked to find the greatest value or least value, you have to make sure that equality is honored in each application of inequality, whatever you are using. If it fails any one place, then you are done, because you cannot argue. It's answerably wrong. So that's one of the things here. And if you look at the batch 4 assignment, you will find we have replaced A with good numbers like maybe 16, 18. X is made 3x plus 4y, 5 plus 11g. So it is exactly the same question. Just you have to make it more carefully. Now, so this I will do like this now. So how we'll convert it, that I can say that, okay, this is A plus X is there, then X plus Y, then something. So I will take A out. This is 1 plus X over A. I'm writing the denominator as such. So A times this one. Again, I take X out. I take Y out rather, because X is the numerator. Y times 1 plus X over Y. Then I took Z out, 1 plus Y over G. And then
Sir, I
took,
think you should take X out. Otherwise, X will be in the numerator a lot of times.
Okay, because you will cancel. Yes, you're right. I changed my mind. Okay. So A times 1 plus X over A. So if I take Y out, this will be 1 plus
Sir, X out, because
X
Z
out,
would not
correct.
cancel.
If
So
I
we should
take
take
X
X
out,
out.
correct, 1 plus Y over X. So you are right, X over A and then Y over X. So guided by this, now I will take here Y out. So I'll get 1 plus G over Y. And then I have to take here B out, so that I get, no, I have to get Z out, I think, right? Or B is all right.
Yes.
No, G, I think. See, because I have to take X by A equal to alpha. I can write here, so that to remind me, beta and gamma is Z by Y. And so now G must come in the denominator. And so I have to take this G out and 1 plus B over G. This I will get. So I can write this as A and then X, Y, and G, correct? A and X, Y, G, and 1 plus alpha, 1 plus beta, 1 plus gamma, and 1 plus delta, correct? let's check delta. Delta is B over G. So it makes sense now that I have taken everything, this kind of thing. So is it clear till here?
Yes.
Okay. Now look at the constraint. Now constraint becomes, if I multiply them all out, I get alpha, beta, gamma, delta. That equals B over A. So everything is fine. And these X, as you pointed out, X, Y, G, they all cancel out. That was the motive, in fact. And then this constant I don't care about, this is A. So now my statement, now my expression becomes P. I'll write in a different color. So my P becomes XYZ, and over XYZ, of course, out. So A times XYZ, and times I have got 1 plus alpha, 1 plus beta, 1 plus gamma, 1 plus delta. Now this cancels, I don't worry about this. So let me turn to the next phase and think of this one. Now the question becomes that product of 4 numbers, alpha, beta, gamma, delta equals B over A. And I want 1 plus alpha, 1 plus beta, 1 plus gamma, 1 plus delta to be minimized so that I can get the maximum. So I write on the next page this, that alpha, beta, gamma, delta is B over A, and 1 plus alpha, 1 plus beta, 1 plus gamma, and 1 plus delta. This I want greater than or equal to this number I'm looking for. So this is simple work, but one care to be taken, a small detail. In childhood, you have done the problem, this kind of thing. A, B, C, D equal to 1. Find 1 plus A. It is an important one. 1 plus C, 1 plus D, any number. This minimum you want. So obviously what you're doing is 1 plus A greater than or equal to twice of square root of A. Similarly, 1 plus B twice of root of B. And two similar numbers. And you are multiplying them all out. So you're writing 1 plus A by multiplying 1 plus A times 1 plus B times 1 plus C times 1 plus D. And this 16 times the square root of ABCD. And you are putting the value 1. So that works, that 1. Change the same question and make it ABCD equal to, say, 16 now. And then I want the same thing, 1 plus A, 1 plus B, 1 plus C, 1 plus D minimum. This
81.
time, of course, no, this is 16 given now. Earlier it was 1. So method works out.
Equality.
I said 81.
Product.
Of course, your method is correct. Let me just tell you that why others will not work. 1 plus A greater than or equal to twice of root A. Each of these problems I am trying to teach some points. Okay, so some of you might not be knowing, and some of you, of course, must be knowing, right? You all have a different experience level. So please try to be understanding for others also. So 1 plus A greater than or equal to twice of root A. Similarly, 1 plus B twice of root B. If somebody follows this, then here he won't succeed. Of course, he will get some value, 16 and a square root of ABCD. You will get something like 64. But for A equal to 2, you see 81 is the 80, you are getting 81. So what is happening is that this value is not attained. Because for that to happen, A must be 1 here, B must be 1, C must be 1, D must be 1. But then product becomes 1, but given to be 16. And so equality is not honored. And so you will say that, okay, this thing is not correct. In fact, we have a strict inequality, and that's the reason 64 is not attained. We have all managed to prove that P exceeds, if this were P exceeds 64, is strictly greater than 64. So if you want to remediate, you have got 3 methods. One method is that you can simply expand 1 plus sigma A, sigma AB, sigma ABC, and ABCD. And now you can apply AMGM on these parts. Like, for example, sigma A plus B plus C plus D. 4 times 4th root of ABCD. This will be 1. Or if you write sigma AB, it is AB plus BC. So these 6 terms. And this is greater than or equal to 4 times again 4th root of. And it will also come.
Sir,
same
6
power
times
will
6th
come.
root. Sir,
6 times, correct. 6 times 6th root. So you can again get this also. Means either you break it up and you get all of them. If you add them up, you will get 81. There is a nice method though. There is an easier one, or more efficient, I would say. This also is nice because I would like it using just AMGM, but it is adding a lot of numbers. Now, one can be that because I hope that equality will hold for A equal to 2. So from beginning only, I will honor this. And 1 plus A, I will not write as 1 plus A, just I did here. Because equality has 3, so I will write this as 1 plus A over 3 plus A over 3 plus A over 3. That's the thing I will make.
A over 2.
2y, 3, okay, here 2, correct. A over 2, A over 2. So because equality hold like that, so I'll write A over 2, A over 2, and this is greater than or equal to 3 times cube root of A square over 4. By making this choice, I have ensured that my equality is honored at A equal to 2 because A by 2 is 1. Similarly, B by 2. And this time when you do it perfectly, this all will, there will be 3 to the power 4, and here you will get, of course, 1, because you will get this kind of thing 1. So 81 you will get. Equality holds when A by 2 is 1, B by 2 is 1, and all those numbers. So the lesson is this, that while trying to apply AMGM, the first thing you check is that you must honor equality at each of the stages. Otherwise, from the beginning only, you are fighting a losing battle. You would never succeed. At best, even if direction is correct in equality, then you will get the answer bound as a strict one, not the one that is attained. And so that will be wrong. Here it might be easy to spot, but sometimes it is very crucial and you are not able to detect that, but you are making the same mistake. At the heart of it, it's the same mistake that people are committing. So please guard yourself against this. Once it is understood, then this is easy because it's just like B by A. So I will write as lambda to the power 4 just to keep things as calculation to be small. So lambda, and I can write like this because B by A is positive. So that's all right. And here, now I will write 1 plus alpha. So I want alpha to be lambda. So I will write 1 plus alpha by lambda. Like that I can write. In fact, if some numbers are given, I can write numbers also. So I can write this AMGM. Never mind, this can be anything because AMGM does not mean that it will be only this one, that integers numbers. It can be actually, you can have weighted mean. So lambda times may not make much sense because lambda is not integer, but still I can use it. And so I can use this one also. Other approach is this. Other approach that I will illustrate here is this. But for that, I would not go into detail because of course, I'm discussing only Cauchy-Schwarz and AMGM. So those of you who have known Holder inequality, this can come in one step. But don't think that all inequalities become simple by using holders. That's a wrong impression. So it means you must have your tool ready, but you must know when to attack with what. It's not that you will use a sword to kill an ant. That would be completely out of question. And that would not so good test also. Okay. So first of all, and by doing that, you are doing disservice to your thinking powers. Now, one thing I'm writing three variable form, Holder inequality. I will not prove it right now, but I'll just write that A1 plus B1 and leave it to you to experiment. A2 plus B2 plus C2, A3 plus B3 plus C3, for example. Holders has got many forms. So it has got an entire this form, like for different numbers. So this is these three the most useful, this one, A2, B2, C2, A3, B3, C3. So I will write this is greater than or equal to. Now first A1, A2, A3. Think of them dimensionally to remember. Dimensionally means think of length, and length. So here I will multiply A1, A2, A3. It will be length cube. So I will again take length. So cube root of this. Again, cube root of B1, B2, B3 corresponding items that you have written. It's your choice. You have to write. And then to the whole to the power 3. So this I can write for holders. A1 plus B1 plus C1, A2 plus B2 plus C2, and like that, A3, B3, C3, cube root. If it was 4 numbers, I can write a 4th root. In the present example, okay, may I also remind you that please look up one Mumbai RMO problem long back, maybe 5 years, in which this kind of thing was given. Not exactly the same thing, but little more creative. So that's a good question. You can check that. Here, I will apply in this form holders. I will say that 1 plus A1, I'm writing general one statement, 1 plus A2, two elements are there, every bracket, and 1 plus AN. This is greater than or equal to. So this is 1, 1, 1. So I'll multiply 1 so many times, 1, 1, 1. I'll take nth root, as told you, length, plus nth root of A1, A2 till AN, and whole to the power n. Dimensions is preserved. That way we will remember why it is n. Now, if you apply that, you will get here 1 plus alpha, 1 plus alpha, 1 plus beta, 1 plus gamma, 1 plus delta is greater than or equal to 1 plus 4th root is 1, and plus 4th root of alpha, beta, gamma, delta, and whole to the power 4 because product is constant, and so you are done. You will be getting this answer. But then I recommend that you can do by this method. This is just that you can read up on some place, and you can just check that, okay, this indeed is also a good way to do it, at least here. But don't kid yourself that by doing holders or by doing Muirhead, things will become really easy for you. It's just that it was just the right thing, so I did here. It just was that, okay, the one thing, it was like, say that just tailor-made for that kind of thing I can use, but not always. So it is always good to hone your basic skills. Very, very important for Olympiads enthusiasts. Okay. Let me take 3 first.
Sir,
Let me show you. Yes, please.
Sir, if in the question lambda is not an integer, how can we use AMGM?
See, I'm saying you can use weighted AMGM. For weighted AMGM, lambda can be anything real number also. But to prove that you need analysis to prove that. Are you getting my point? But you can use that because in exam, they don't ask you to prove it. You can write by using weighted AMGM. Are you getting my point?
Yes.
Or you can use means also. Okay, let's go to 3 first. XYZ positive real number such that this one. Prove this. Can someone try it for 2 minutes? It's not more than 5 minutes. So just please try it. Here I'm giving you time because it is not longer. And very simple problem, but still I will tell you what the philosophy is behind it. Till the time I'm writing it, I'm turning the page and writing it. Yes, I would invite the discussion. Just offer your thoughts, at least one.
So
Then by induction, I would know many of
you
you are
already holds at 112, so we can go in that direction.
Good one. This is
the squares.
Okay, that also is one good thought. Okay, so
Yes,
but
sir.
I would
So we can use AMGM.
AMGM on which numbers?
We can separate x square plus
You can split first. You're saying you can split, right? You're saying split.
Sir, we can replace 10 by 2xy, 2yz, 2zx, and
That I knew, and then hope to complete the square.
yes, sir, that would work.
Okay, suppose it was something else, not 112, something very crazy, √2 and something. Okay, so it's good to hear from you all. So 2 comments I like the most. One is that this one, that equality holds at some point, somebody told, and then we can go in that direction. Of course, what he meant is not clear, but still I will show you how to go in that direction. And other comment was that okay, we can try to split. But then again, the rub lies in finding the correct splitting, because you know that it is easier said than done. Sometimes you may not have idea that how 3 is made up of what? 3 may be √2 plus 3 minus √2. Maybe very crazy. The other 3 may be √2 plus 3 minus √2 or something else. So I will offer you one really good insight. And 3 second, I will show you 3 second, which is a Chinese TST problem. Say, or maybe China National Olympiad. Not sure about these two, but the good one. Second, it is really good. But exactly whatever I do in 3 first, I will do here. Those who said that I will replace 10 with 10 times 2 times xy plus yz, they cannot do something like this here, because everything looks so symmetrical left side, right is not. So there is something going on. Completing a square, of course, still that also is a problem, because they are not x minus y. You do not know what this x, how this x splits. This splits very badly. Something like a by a plus b, b by a plus b, Of course, you can have your thoughts about it and you can have intuition, but not easy. I'll give you a very systematic method which will really kill it. This I have applied to many problems. See, what I do first, I suspect, of course, that these three will means I am not worrying about these three. Numbers, for me, numbers have a way of cropping up. They will crop up, guided by the problems in the problem, in the number in the problem. What I will most care about here, that if I can find equality case, here it is easy to know that 1, 1, 2, because you know these numbers make up 5 and this is this. Sometimes it will not be easy. Then you solve these two equations and try to get one set of values. You will succeed. So you will get this.
Actually, I got a solution.
Okay, so you can wait. Let me complete now. That's good. You got a splitting or what?
And just expand first z minus x minus y whole square greater than equal to 0. Then we can expand x minus y whole square greater than equal to 0. And adding to twice the second equation, we would be done.
Okay. Let me now offer my thoughts on it. So please, all of you, this is a good motivation that I am doing. So please try to understand this.
I also got a solution.
Okay, good enough. So let me now solve it and give the philosophy behind it. You all will gain from it. Either you have solved or not solved, but you will gain from it. Okay. So these three I'm not worrying right now. 1, 1, 2 is the most thing that I worry about. These 3 or 4 have a way of cropping up. They will come up. These numbers will come up themselves. I don't go after them. They will come after me. Now 1, 1, 2 is there. So how do you prove x square, y square, g square, xy, yg, gx? One is sum of squares. Other is that you are applying x square plus y square greater than equal to 2xy, y square, g square, 2yz, and similarly adding, and then it goes away. I'm doing the same thing, but not on these numbers because they're not symmetrical. So what I do, in an order to honor my equality, I will apply on x and y, I will apply x square plus this is y square. So x1, y1, g2. So I can apply x square plus y square greater than equal to twice of xy. This I will write. When I come to y and g, because y is 1 and g is 2, 1, 1, 2. So what I will write here y square plus g square by 4, means applying on y and g by 2 because they have a chance to be equal. So y square plus g square by 4. Let's see what it gives me. This is greater than or equal to, this is just gy because 2 times will come. So this is gy, y square plus g square, or yz I will write. This is yg. Similarly, this is x square. So g square by 4 plus x square. This is greater than or equal to gx. Now I will say that x square y square is 2xy. So now you see some way that how to complete the solution. See, multiply this by 2. Multiply this by 2. First option you leave as it is. Don't multiply anything first. See, this is 2xy is there, dear. 2. You want again 2. You want this coefficient to be same. To multiply this by 2 and this by 2. Don't go looking for this one. This is exactly all right. Means even if it was 4 or 11, I would not mind. Ratio I would make same ratio. So I would coefficient 1, 1, 1. So multiply by 2. Things has to fall in place. Things have to fall in place. So this is I know that x square and 2x square, that gives me 3x square. I'm looking. So it came itself. I did not go for it. I just went for my constraint and things were ordered. So 3x square plus 3y square. And by the time I reach g square, I found this also is taken care of because g square by 2 comes twice. So g square, and this I get 2 times now xy plus yg plus gx. So that gives me 10. Is this method clear?
Yes.
Yes.
It is a really powerful method. Balance the coefficients. Learn it. It's my experience, and so please make use of it. I will just, yeah, please tell.
Sir, just confirming, sir. So we got the idea of z by 2 from the solution of 112.
Yes, equality case.
Okay, sir.
This is very, very important. So I'm telling you that you will get equality case. This kind of examples you get in often many contests where solution is one line. You will think that they will write observe that, or write 10 as. But then you are left gasping for words. Okay, how do I observe this and how do I get that? So you make some connection that okay, 5 is to 10 or 4 into 2, 8. I will do something like that. That's very flimsy. So I experimented with a lot of things, and I then got that, okay, this might be a nicer way to get at the heart of it. Watch it actually happening. So I'm not worried about 3. They will come. Design of the problem. See, if somebody gives me constraint as 2xy plus 5yg plus something blah blah, then I will just write first. I will not care about 2, 5. I will write in xy, yg, and gx, whatever coefficient may come, lambda, mu, and nu, and I will multiply by suitable numbers so that ratio is maintained 2, 5, and then I can take it out. Is that clear? Means whatever
Yes, sir.
constraint you give, I will honor equality. And I know in my heart of hearts that coefficients have a way of occurring. This 3, 3, and 10, they will come. It has been designed. Once I take care of my constraint, things have to show up because they are preordained. Somebody has designed them. They will themselves show up. I don't have to go looking for them. They will come looking after me. That, okay, where are you? I want to be in. Okay. Similarly, if you do this one, let me just show you that one. One interesting. This is very interesting problem. That one, that ABC positive real numbers, simple and interesting, charming. So here, what you do, that things are not clear. So I will just start off from the left part. Here you apply in this form. My handwriting is a little small, so you might have difficulty in seeing sometimes. I apologize for that, but at least you can hear me. My voice is strong. So God has compensated me for that. Okay. So now let me write this way, that it is x square plus y square plus g square. This I want something. Big numbers. I do not care. What I do, that I write here alpha x square. Remember this philosophy, that to prove this, which we never care, to prove this, one method was completing the square, bringing to the left side and writing as a sum of 3 squares. One method was apply apply a square plus b square greater than or equal to 2ab, not mgm, because things are not positive here necessarily. Here it is positive. So this is this you write. So take them in 2s and then add. Here also same thing I'm doing, taking them in 2s, but then I know how to do it. So alpha x square plus beta y square. I will write 2 times the square root of alpha beta xy. Things are positive. And once I have taken alpha and beta, here I have no choice but to take 1 minus beta y square, and plus g square, I will write gamma g square. So some constant again will come, which I don't care. And now once beta is there, it's taken care of. Gamma taken care of alpha. So now I will write 1 minus alpha x square plus 1 minus gamma g square greater than or equal to. Left side is maintained now. I needed that. I made that. Right side, now I will choose alpha beta because I know this one. I know some ratios, and in that I can choose. And you will. It is a good exercise. Please complete it later. You will find it to be rewarding, and you will get it done. You can also find out where the equality holds. So I've given you when does equality hold, because it's not trivial to find out. It takes some work. I hope it is clear. Any doubts on this? The method especially. Okay, and try to create one more problem of yours by taking some random conditions.
It will be a bit lengthy.
No, not lengthy. It will be easy. It will be a systematic method. Very, very structured. Because this you won't get by just simply guessing around that magically split x square in something. Unless the solution says same thing, that observe that it is sum of these 3 squares. End of the story. That does not give you much idea about how it strikes you as unusual, right? If somebody writes you root a plus b upon b plus cx minus this upon y and plus 3 similar terms. So try to get into it, that what is really happening, what is going inside, as far as we can do. Okay, so let me go to number 4. Again, number 4 hides a beautiful identity and some good results. So I'll write it. I choose my problems very carefully. So if you work through it, you will really gain a lot from it. 1 plus BC over A, 1 plus CA over B, and plus 1 plus AB over C. This is greater than or equal to twice of root 3. Okay, so this we want ABC all positive numbers. Okay, so one thing is this, that A plus BC, that many of you know, I can write as, because this is 1, I can write this as A times A plus B plus C plus C. This one is C. So this is A square plus
BC, sir, at the last.
BC, A times C plus C plus
Yes,
BC.
sir.
So that is A plus B times A plus C. That is one thing. So in effect, you have got three numbers here. One number I'll write here, a plus b times a plus c over a, n plus 2 similar. So direction suggests that I can apply AMGM. So I let greater than, so there is no need to discard it. Let's see how far it goes. Greater than equal to 3 times and cube root of, okay, and then multiply all those numbers. So I get a big square root, and inside I have got a plus b.
So how to think of this?
AMGM is the first thing, because see, you have got three numbers here and direction is greater than or equal to. So you will have this one. Other motivation is that a plus b, b plus c, c plus a, something, 8 ABC, something is there, right? 8 ABC and some more that I will tell you now. So this kind of thing means first start with simple things that, okay, this is there, greater than equal to this.
No, but this
times.
manipulation about a plus bc.
A plus BC, agree that a plus BC, you must have some experience in it, a plus BC. Write one as this one, a plus b plus c, to make it sort of homogeneous, or otherwise also it is same thing that you can think like this. But this is might be better, that a plus b plus c. So degree is same. This degree is 1. This degree is also 1 BC over a. Okay. Anyway, this occurs quite often. This is actually part of algebraic identity. You will find many problems in a small contest. They will give you that a plus b plus c equal to 1, or a b b c c equal to 1. Find the value of 1 by a plus b plus 2 plus something. So you will get some answer, 13 by 11, 18 by 9. Some contest will give you like that. So this I think is reasonable. These people know, many people. Okay, so based on that, what we do that now, I am writing this one, that so 3 times cube root of a plus b and all those numbers, and upon ABC. So we are getting here. So you are getting here 3 times cube root of, and this is your a plus b times b plus c times c plus a, because the square root goes away, but in the denominator it is still there, square root of ABC. Now this one. So it means if I can bound this from below, some number will come, of course, that will multiply and make it 2 root 3. So this then my work is done, and given a plus b plus c is 1. Now if I write like this, that a plus b plus c, so in an attempt I will ask myself ABC first. Ask yourself, how do I connect this one, a plus b plus c? So we know that this answer is 8 ABC, but we have got root ABC. So even if you take one root ABCs, I just peel it off, and other I keep root ABC, then also I won't get, because now direction is not correct, because I want greater than equal to, but because of constraint a plus b plus c equal to 1, a square root of ABC will lead this less than equal direction, because it will come from cube root of ABC, and less than equal to will come. So this is not the correct thing. I repeat, in an attempt to bound this from the lower end, like greater than or equal to, because that's what you want. So I will think of this one ABC part of this root ABC I keep, so I peel it off, and the other part root ABC I want to bound. I want to get something like root ABC greater than equal to. This I want to get, but sadly I cannot get it using AMGM, because a plus b plus c is one given sum. So product will have the direction of less than or equal to. Whatever value comes up, I'm not worried, but direction will be, of course, not correct. So this is not the right choice. It is not the correct connection. Let's now ask, and first let me ask you all, that do you know how to connect any other thing comes to your mind? A plus b, b plus c. When you see a plus b,
Yes,
b plus c,
sir.
c plus, it's very open question, but it's still
AB plus BC plus C.
greater than equal to who? And no, a plus b plus c, c plus a greater than equal to 8 ABC is known from ages, right? Childhood friend is there. No, first example it happens in all book. So what is the next example? Do you know one inequality that strengthens it?
8 by
It's
9.
not famous. Yeah,
that.
8 by 9. That is very good. For me, it is just like a little lemma and gem, which I always use. From the first time I saw, I knew that it was the one. So this is 8 over 9. All of you please make note of it for future use. AB plus BC plus C. Anyway, I will be sharing the PDF also, but you make a mental note. This one. This, of course, is a strengthened because this is stronger. 2 is stronger than 1, because if I apply on these two AMGM, I will end up at 1, but 1 cannot prove 2. Of course 1 is weaker, 2 is stronger, so 2 will imply 1. 1 of course cannot imply. So this is one inequality which I will write, and in fact one more good thing will come here.
Sir,
so
what is the outline of proof?
yeah, I'm proving it. I'm proving it just now. I need to prove it because I need to give identity behind it, which is again useful in its own right, very much useful. So stay with me. Now, I want to put this is a small proof, but some people can expand it also and they will check it. But there is a nice proof based on some identity which I'm writing. The identity is the following: A plus B, B plus C, C plus A is equal to A plus B plus C times AB plus BC plus CA minus ABC. Really, really useful. I have found at least 3 APOMA examples, APMA problems. 2 I used in INMOTC long back, and then I found one boy who later went on to win some medal. He of course knew and used it exactly correctly, because sometimes when you know a powerful identity, just like geometry configurations, that you know something beautiful about it. Now, to prove it, either you can expand it simply, so that is verifying, or there is a proof through polynomials. That's a like elegant proof. An elegant proof. I can write t minus a times t minus b times t minus c is t cube minus a plus b plus c t squared plus ab plus bc plus ca times t and minus abc. It's just 2 polynomials. I just expanded in symmetric fashion. Sum of roots taken 1 at a time and 2 at a time, because these are the numbers coupling. They have a special significance. You have been able to write left as a symmetric combination of things, no, like sigma 1, sigma 2 minus sigma 3. That's the importance. Now, put t whatever you like because it is an identity. So I can select t equal to a plus b plus c. So you get left hand side in some order a plus b times b plus c times c plus a, which matches with the left hand side of the identity. And here, notice that these two, they will vanish, they will kill each other. If you write t squared, here, t square common, t minus sigma a and plus. So this will go to 0, and you are left with here a plus b plus c times ab plus bc plus ca minus abc. So we have proved this identity just using this factorization. Is it clear? Some polynomials we did. Okay. Yes. Now it is easy because I have to prove this. I know that this is equal to this. So this, I will replace this part by other thing by using this identity. So I will say that proving this is equivalent to proving a plus b. Let's keep a plus b, b plus c, c plus a greater than, or bad notation here, right? That is means it is equivalent to proving this. It amounts to proving this. It is equivalent to proving this. All sorts of words. 8 by 9, and this I can write as a plus b times b plus c times c plus a plus a b c. I take this 9 this side and do some transpositions. Then I will get here a plus b times b plus c times c plus a greater than equal to 8 ABC, the famous inequality, the simple one that gives you okay, this is okay. So I get this one. So it means by this identity, I have cleverly reduced this inequality to the first inequality, very special. So this we must remember this one. Okay, so far so good. Now we have forgotten that what we set out to prove, right? Okay, so I will just remind you again. Now, so I had to find out a plus b, b plus c, c plus a upon square root of ABC. How this behaves, like what is this kind of thing? This I had to find. So I'll use this, that okay, a plus b, b plus c, c plus a is greater than equal to 8 over 9, a plus b plus c, and ab plus bc is an interesting problem, ca. So I can write 8 by 9 because a plus b plus c is 1. So till this far you have reached. But still your job is not done. Because if I apply AMGM now also, again, it will come cube root of a square, b square, c square, that will not cancel. And moreover, I can't bound it also. So those kind of thing will come, that you won't have anything useful again. So how to get this impasse now? I hope that this you appreciate. That is still my job. This is a powerful inequality in its own right, very powerful. So those who have reached till this point, still it is not over. There is a small detail still left. The problem still has some life in it. It's not dead at all. So now what to do? Can you give just a quick thing that, not solution, quick idea that what should I try?
Add a plus b
Actually,
plus c and subtract that.
No, that is no. Already we have done this. Already we have reached till here. Don't reinvent the wheel. We have reached till here that we know this one. Now, if I can prove, now my question is that how do I bring this ABC sort of here? If I apply AMGM,
Sir,
HM,
if we could,
not working.
sir, if we could do something like if we could bring one, like if we could reduce the degree of this and bring ABC things in the denominator, then we can bound it. So
Don't think of degree.
maybe.
Don't think of degree. Degree is deceptive here. Why? Because same thing I tell you. It is deceptive because always you are thinking of degree 3 is there up and down is not so. See, okay, I ask you this question, that how does AB, BC, CA relates to ABC and A plus B plus C? Do you know something that connects AB plus BC plus
We
C?
can square them. We can square them like the Cauchy product thing. It
Now,
will
1
be
minute.
A plus B.
Sir,
Just a
AB plus
moment.
BC plus CA whole square is equals to A plus B plus C into ABC.
AB
No.
plus, come again? No,
Is greater
not
than equal
like
to.
that, but still you are on the right path maybe. See, listen to me carefully before you rush to answer. Okay, it is more of a dialogue, and more of, because of course time is also not like time is a premium. We don't have much time, but still, what I am saying is that the correct question to ask ourselves is this: that how do I connect AB plus BC plus CA to ABC? Don't ask about degree right now. ABC, just ABC. Maybe it will have a way of cropping up. It will come cube, or I do not know. Means I'm saying that how do I connect AB plus BC plus CA, or do I know something, in as Edos would say, that do I know something that relates AB plus BC plus C on one side and ABC, product ABC, and possibly A plus B plus C on the other side? Why A plus B plus C? Because I know it. There is a famous inequality here.
So 2 times AB plus BC plus CA, like 2 times AB into BC plus 2 times BC into CA.
No, I will tell you this. No, I'll tell you this. See, all of you know it, but then not used correctly. A plus B plus C square greater than or equal to 3 times this one. 3 times AB plus BC plus CA. But this is the opposite side, right? So what you do, you apply on ABCCA. So you write it as AB plus BC plus CA whole square greater than or equal to 3 times ABC will come out and A plus B plus C. This is what I was looking for. Comes from here only. This comes, of course, from the mother inequality A square B square C square greater than or equal to AB plus BC plus CA. You do some gymnastics and you get here easily. So this I am looking for. This is one of the really important ones. You check some RM or INMO examples which directly make use of this one. Other solutions you will get many. You will move in circles. Here, if you use this, there was a question that this cubic equation has root lambda something. Prove that lambda less than 1 by root 3. Directly you will get by this one. It was in that language only. Okay, so if you see this one, then you will get here AB plus BC plus CA greater than equal to, and then cube root of, sorry, not cube, square root of 3 times ABC you will get here. Now that's correct. And this goes off. So degree was taken care by A plus B plus C, not ABC. So this is 1. And now you are home, because root ABC cancels from denominator and some number root 3 comes up. So you're getting 8 by 9 times root 3. So that is 8 over 3 root 3, this one. And if I go to the previous page, you see it was 3 was lurking here, 3. So I can, so this, my answer would be now that 3 times, and this is 2 over, because Q will take 2 over root 3. So that's 2 over root 3, this one.
So but sir, how to think of this solution? Like we were stuck at some point, so at that point we might even think that our method is long, or maybe we are going in the wrong direction. So we think of something else.
That can I have my sympathies for you. That can happen, dear. Truly, it happens to each one of us at n number of times. But the point is that first of all, I tell you that try to connect basic inequalities, means try to ask the question that how to connect AB plus BC plus CA to ABC possibly. Don't bring in degree. That's the one mistake people do. Don't bring in degree, because degree thing is really spoiled by those conditions, A plus B plus C equal to 1. And possibly that is a curse that many of us go in the wrong directions, because we think more, we give more to degree. And I think the opposite. I think that degree has its own way of cropping up. Let it crop up. I don't care. I first care that how do these two relate, and then I will say that, okay, can I bring the degree now? So once I this is a famous inequality. This, no doubt, ABC square. This one I can give you a number of examples, and I love it also. So I will use it shortly in 5 also. Next question. So this kind of inequality is the right thing that you think of, that okay, ABC is there, ABC, so this is the connection, and then you can think of that, okay, it works or not. If it works, all right. Otherwise, you are back to drawing board. So first, start from obvious, most famous inequalities. It's like that, okay, can you name the most versatile one that somebody knows about this? There can be so many things, so many inequalities. Examiners also are doing same thing. They are looking for something very simple, yet application is in ingenuity, means really clever ways, combining clever ways, but it must be simple. If you look at the past INMO papers, many of you must have noticed the trend that now, like last time also, now you are not being given the question which routinely will work, in the sense that, okay, like, and not technique based, that okay, if somebody only knew Karmata or Muirhead, then only he had a better chance to do, or somebody knew some Thus lemma, then only he can do the number theory problem, otherwise he can't do. Nothing like that. Means the HBCSE people like that you think in a creative ways, and you know that you have got at your disposal all the techniques. So don't worry unduly about the techniques that some friends of yours must have mastered by using some kind of arcane books or some kind of sites. So I hope I make myself clear. Okay.
Yes.
Okay, let me go to the next one. Let me check this. Yes, correct. So this is an IMO problem. So normally I don't write sources because people unnecessarily get disturbed by looking at IMO shortlist, right? But it was an easier one, 98. And actually it will come by Cauchy-Schwarz. So first I'm not doing, I'm saying that second is same as first. Means when you do it, you will find that, in fact, if you do first application, if you do the simple application of Cauchy-Schwarz in T2's form, then you will find that immediately after one step, proving first is exactly the same, equivalent to proving second. So instead, second I will prove. First, you can just write as s to the power 4 upon x times, and then it is just a routine thing. The second step is this only. So I have started this one. Means in a real exam, I could uncover this. First, I need not ask. I can ask somebody second only, because I know that people have become expert at applying T2 inequality. So don't ask that. Directly ask this kind of thing. Or getting the same idea from here, I can change the numbers 4, 9, 11, 3, 6 by some suitable other numbers, which is easy to do because I know the method now. So it is easy. So let me prove this one. 4 times something looks like this. That say degree is a bad here. No, you can't go about adjusting degrees first. That xyg is there, so multiply by xyg first. Here is square, here bad. Don't do that. That's my suggestion. First of all, something that matches with number 4 also. So let me write second, 5 second. So I have to prove that 4 times x square plus, I will guide you through my thinking process, and certainly you would gain from it. 9 plus 3 times x plus y plus g plus 6 times xy plus yg plus gx. I don't believe in doing n number of problems, but I believe in doing k number of problems less than n. N may not be very big, k may not be very small, but then I must get to the gist of it, to the heart of it. I must get something more out of it. It's not that simply that this is a problem for me. I know ins and outs, and I ask myself right question, and then it like this becomes my own. So this kind of thing you should do in most of the problems. Try to find motivation, because it will take some time. It won't come easily, but you can ask yourself questions, and then you can get the right answers. Because in exam, because in writing solutions, author don't have a time to write all the false starts, or all the incorrect first test steps that he took to arrive at the correct reasoning. So that is your job. You have to do this work. Okay, so here this I have to do xyz equal to 1 given this one. Let me check my question. Yes, correct, this one. And positive real numbers are given as usual. The way in physics we are given that friction is absent so that you can apply some good laws. So those positive things are given to you. Now, so I ask myself following, that how do I connect x square y square g square to constant, some constant? I do not know what that constant is, 1, 2, 3, 4. How do I connect x square y square g square, or possibly its power, preferably second power, to again x plus y plus g? And xyg may come. Keep in mind xyg also may come because this value I know. So everywhere xyg may come, that I have in mind. And how do I connect x square y square g square to xy plus yg plus gx? Or a square, preferably a square. So this is the way of thinking. So ultimately what I will do, I will be able to write x square y square g square whole square greater than equal to some constant lambda, and same number greater than equal to some sigma x, and same mu sigma x, and then nu sigma xy square. And once I'm able to write that, I can take a linear combination, means I can multiply this by say 3, this by 4, this by 11, according to the needs of the question, and then I can get my answer. I repeat, I ask myself the following 3 questions. How do I relate in a simple way, or if I know that x square plus y square plus g square relates to some constant, given of course xyg equal to 1. How do I relate x square plus y square plus g square, preferably squared, to x plus y plus g? It is linear term. So degree I will not look for. I will just say, and then degree I will adjust. And similarly, again, third question, that how do I relate x square plus y square plus g square to xy plus yg plus gx? And preferably a square is there, and this is linear. So first job is simple. Not all are actually okay. X square plus y square plus g square is 3 times cube root of x square y square g square. And because it is given to be 1, so I will write 3. Normally what I do when I research on that, at that time I don't write, I carry it. Mind you what I'm saying, I carry it just to not lose degree. I carry it. At the last step I put it. So I keep carrying it so that sometimes it gives you new insights that, okay, keep carrying it. This is actually, it is hiding it. So actually it is this. Actually it is this, degree is all right. But because you have given x y g is 1, so it becomes 3. And so if I write x square y square g square whole square, I have to connect. That whole square greater than equal to 9 it becomes. So something there. Right now, don't worry about that this is accidentally 9. It may be 18 also. So don't be too early to conclude that this 9 is there, so I get at least 1. But some idea you get that this 4 is getting a split in some parts, and every part will correspond. That's the beauty. You cannot compare, one size does not fit all. You cannot as a whole prove. So you are connecting 3 different things and making suitable linear combinations that, okay, multiply by some constants, scalars, and then get your job done. Next one, this one, x plus y plus g. Here what happens, that I know this thing, 3 times x square plus y square plus g square greater than equal to x plus y plus g whole square. This is by Cauchy-Schwarz. I know this exactly. But see, if I square it, you see it is 4th power will come and something else will come. I want only x plus y plus g. So what I do, that I will write here, because I know that x plus y plus g is greater than equal to 3. So what I can do is that I will write 3x square plus y square plus g square greater than equal to, I will write x plus y plus g and times x plus y plus g. I will split it up. I'm losing the degree now. So I'll split it up. I don't know, when I do this, then virtual image comes something. Okay, let's do. Okay, so this is greater than equal to, this is greater than equal to 3 x plus y plus g, thanks to the condition x y g equal to 1, that becomes greater than equal to 3. So this becomes 3 times x plus y plus g. So I have got x square plus y square plus g square greater than equal to x plus y plus g. This I got, 3 cancels. But I want to relate a square to this. So again square it. So x square plus y square plus g square whole square greater than equal to x plus y plus g whole square. But again, I want only linear. So keep 1 x plus y plus g. So this you write as equal to x plus y plus g and times x plus y plus g. One you cleverly keep because you want one only, degree linear, and this you substitute by greater than equal to 3. So in effect, you have got x square, y square, g square, whole square greater than equal to 3 times x plus y plus g. Let's check it. This kind of thing you got. X square, y square, g square. Or you can directly also write and you can again plug those numbers. So in any way, you got this one. X square, y square, g square. So first I will write this one. This is 1. Then I was connecting this one, that x square plus y square plus g square whole square greater than equal to, and I got 3 times x plus y plus g. So it looks all right. Okay, don't worry, don't connect right now 3 and 3 and be happy 3 is there. It may be just coincidence, maybe it might have been 11 also. So I'm not worrying about this. Why it is 3, it will come clear to you in a while. Now last step is you have to now connect these things, but again linear. For this, what I do, I write x square, y square, g square greater than equal to xy plus yg plus gx. That's all right. But a square is there, so I will square both sides. So x square, y square, g square whole square greater than or equal to xy plus yg plus gx whole square. And now the one thing that I did, I want only xy, yg, gx. I do not want anything else. So what I will do is that I will keep xy, yj, gx 1. So xy, yg, gx I keep 1, and 1 I separate xy, yg, gx. And this is greater than equal to 3 times again cube root of x square, y square, g square. So again it is 1. So this is 3. So it means from here I got x square, y square, g square whole square greater than equal to 3 times and xy plus yg plus gx. Now let me box all these things that I got. This one, and I got this one third. These 3 I got. Now let's look at the problem. It is 4. You want this one. So 9 is all right. This is suppose P. Expression is P. I want 4P greater than equal to something. So this is P. This also I keep as it is. And last I multiply by 2 because I want 6xy plus yg. So I know that, okay, if I multiply this number by 2, then I will get here 6. And when I add, I will get exactly the way it is, that 4 times x square plus y square plus g square whole square greater than equal to 9 plus 3 plus 6. Mind you, you could create your own inequality. You can multiply this by random number 8, then 11, then 13, and you will get some other coefficients. So all of you can create different possibilities. But the one who knows that this might have come due to some split by connecting x square plus y square plus g square to first a constant, then to sigma x, and then to sigma xy, he will truly know. He can see the game. He will see through the game that yes, this is what makes it work. And then he will quickly go on finding the right coefficients and the right relations. Is that clear?
Sir?
Yes.
Yes, please ask your questions. I will come.
Sir, like when you split that like 3x square plus y square plus z square greater than that thing in
Correct.
2 parts.
Yes.
Sir, weren't you like having a fear that you would get a like weaker bound than what you need?
Yeah, see, you are very right. That can happen. So I have to revise my strategy. That can happen. Means here my first thought was that maybe if I directly deal with it, is no way. Means directly if you deal, see, normally I do not go for this kind of thing, that this bunching, that suppose you open it up all and try to find right combination. That might be really tricky. So first you must try for that, okay, basic things, like let me relate these things to simple things. So if it did not work out, this one, then of course means that I cannot do it in parts. Then maybe I have to break it. I have to completely expand it, and then I have to think of some new idea. That can happen. For example, some inequality is Sur inequality, sure, they are stronger, much stronger. So it may happen also sometime.
Like
so your question is right.
From the third only.
What you saying? Please come again.
So I was saying that we are getting the first inequality from the third only, which we are adding up finally. We're getting it from the third only.
First from third only means what? This total inequality or only one part?
So parts, I'm saying that it will be a weaker bound, I think.
No, right now we are getting correct bound. Now we got correctly here from
So saying
in
that
our case.
in third inequality where we're getting 3 into xy plus yz plus zx,
Correct.
from that only we can get the first one greater than equal to 9. So this thing.
Okay, that we can get. Yes, that we can get. Yes, that can happen. That we can get. So first of all, I used first. 1 minute. I used first because it was very easy. Constant. No, constant was very easy to relate. And then we got. Of course, this third is stronger than the first. That you are saying, correct?
Yes, so.
Yes, that is correct. That can happen, but does not matter. Like we have to connect in the end. Yes, other person was asking somebody.
So,
go ahead.
If we find that when x is equal to y is equal to z, the equality holds. So, sir, how can we proceed forward from there? Is there a way?
Yeah. So that is same thing we are doing. That what we are doing that we are not being greedy at a time. What we are doing that we are applying in parts. So when you are applying this one, there you are taking care in this one that equality is honored. So everywhere equality is honored. See, in all of them, 1 1 1 is honored. 1 1 is honored. That's what we are doing. Okay, sir. You cannot begin in the beginning only. That there only you can't split something like that, because see, degrees are different. So you cannot match. So here we quickly realize that degree is spoiled because xy is equal to 1 can be very erratic. It can be x to the power 4 by 3, y by 4 by 3. It can be y square, g square. It can be any other thing. So we did this approach that we created simple thing. And mind you, this example, in fact, this question, AB plus BC plus CA whole square 3ABC, this occurs in so many places that AB plus BC plus CA whole square greater than equal to 3ABC A plus B plus C. Many questions. Even you will find some question on tetrahedron that this proof that the volume satisfies this. Ultimately, I found, oh, this is this only, written some other way around. So they are really powerful inequalities. And much more frequently studied. Yes, go ahead, ask the question.
So sir, I got the first and third inequality. So could you please repeat the second one where we repeated, where we related?
Of course, I will do it on a fresh page so that you can learn better. That is too crowded now. X square, y square, g square, I had to relate. So write 3 times this. This is one known inequality, right? Nobody will deny it, that this is one thing, a reasonable start. But because, dear, I want only x square plus y square plus g square whole square, this I want to relate to x plus y plus is linear. So I cannot keep all 2 of them. So either a square here only, or first here only I write greater than equal to x plus y plus g and times x plus y plus g. So 1 I replace by 3 because I know that x, y, g equal to 1. So this is greater than equal to 3 times x plus y plus g. Means in effect, I keep only 1 degree. I deduce the degree. So I get x square plus y square plus g square greater than equal to x plus y plus g. Now I can again square it. So x square, y square, g square whole square greater than equal to x plus y plus g whole square. And I can again keep 1 x plus y plus g, and other I know again that greater than equal to 3. So I will like this is greater than equal to 3xyg. So I've connected. Or here also you could have done a square directly also first, and then 1 you keep x plus y plus g, other you replace. That also was fine. Got my point?
Yes, sir. Thank you, sir.
Okay. So let's go along. We have 12:50 it is. Oh, it's like you have been asking too much questions. Okay, so let me finish 2 questions at least. 7 and 1 more I want. 7, of course, 7 I will show you. So the next page, I can scroll and show you. Okay, see, this is 6, 7, 8. They all are based on T2's lemma in Cauchy-Schwarz form. For IMO 2015, you Google, you will find a good solution due to Yuri Boiko, who got a special prize IMO for his solution. You do check out his solution also. Of course, there are many solutions to this, but his is, of course, he got a special mention, special prize, as is customary at IMO for his creative solution, very creative. So you can check that. Maybe he was a Moldova contestant. Okay, that one. I will do 7 to offer some kind of advice.
The name of that person, only if
Yuri
I will search
Boiko.
IMO 2000.
Yuri Boiko. Boreico, and Yuri is IURIE. You can check that. If you say IMO 2015, they will of course guide you, or you write a special prize. Anything you write, Moldova, No, they will. So he got a special prize for his this one. It's a nice solution. It was. Okay. I'm giving you a solution which is based on 7 I will do, and 8 you can apply later on this. See, 7 is this one. It looks too much like crazy, right? One, there is no sense in it. Y plus G, you cannot connect anything. So possibly your thought is this, that I will take maybe 5-10 minutes longer, in which is lunchtime. So 1 plus Y plus G, and upon 1 plus X, no, 1 plus XY plus XG. So I have to do 1 plus XY plus XG, and over 1 plus Y plus G whole squared, and plus 2 more things greater than or equal to 1. Okay, this is what I want. So now, see,
they are positive.
They are positive. Yes, things are all positive. No, 9 out of 10 times things are positive. Just like in physics problems, friction is absent always, right? So then you can apply the laws carefully without worrying about all the details. Multiplying, keep multiplying at your will. Okay. Okay. So now, so this is now given, and given xyg greater than or equal to 1. No, nothing is given. Just positive real numbers. Now see, for me a question holds its importance because of the motivation. So I will motivate the problem. So motivation is like this. This is really helpful for all of you. 2 methods I will tell you of looking at the same thing. So one is this one, that we apply Cauchy-Schwarz like this: PQ greater than or equal to R square. I'm writing means PQ is same thing, that PQ is something A1 square for 3 variable, A1 square, A2 square, A3 square, B1 square, B2 square, B3 square, and again A1, B2 square, this one, which sometimes I prefer to write as A1 plus A2 plus A3, because things are not always squared here. It may be something, maybe cube, something maybe this one. So write like some numbers. There's some numbers, B1, B2, B3, and here you are writing their GMs, geometric mean, like A1, B1. You are writing root and root and root. So like that you make your idea, because sometimes you may have to apply on A plus B square plus C cube. So it is not a square. All are not a square. So think like this. So it's like three numbers here, and then you are taking geometric mean here also, and squaring it, or sometimes root. So R square is there. So possibly I want that 1 by, so if I write greater than or equal to sign I want, so maybe that I can write P over R square greater than or equal to 1 over Q. This I can write. And if I choose this, then maybe that I will get some answer. That is my thought. And for it to work, my Q should be such that it should be common to all of them. Means denominator must be common. See, this is here P will be different. Here it is 1 plus, let me check what, yes, 1 plus YG. Here it is 1 plus, let me write one more, YG plus YX over 1 plus G plus X whole square. So now my P and R will change. R will become this. But I want to make sure that my Q does not change, so that at least something is common. Is the motivation clear? First of all, I am trying to create common denominators through inequality. A technique that all of you have learned through childhood, that your teacher told you that if something you see, then try to make all of them denominators first equal by changing sign or something doing, so that they are on the same platform. It is easy to just add them up. So I'm trying to create a common denominator. In the hopes of doing that, I am applying Cauchy-Schwarz. So I have to bet on Q, that what Q might be. So what common denominator I want. So I write like this. So now I start here. So P is anyway fixed. I cannot do anything. So that is 1 plus XY plus XG times. Now, and this is greater than or equal to, this is your 1 plus Y plus G whole square. So the choice is clear now. What I do here, that 1 is there. So I can write here 1. So I have to write GM, 1 GM is 1. Then XY is there and Y GM. So I can write here Y by X, because then Y is square. So Y will come. Here I can write Z by X. This is the step, basic step, that I choose like this. So it means I can write here that 1 plus XY plus XG, and upon 1 plus Y plus G whole square, this is greater than or equal to, sign is also correct, 1 over 1 plus Y by X, G by X, which beautifully goes at X over X plus Y plus G. And then we are done, because we write two more such things, add up all the 3, and you get perfectly 1. So this is the one motivation behind it. So this you are creating. So thinking that R square does the job here. So is it clear? Is this clear that how I'm doing it?
Yes.
I started with these two in mind, and then I plugged in that I should keep here something such that GM of this and this product and take a square root. This and this product, take a square root. This and this product, take a square root. So I'm helped by this. And then let me weight that what I'm getting. And to my surprise, I got O because they're design problems. So maybe you not get much wrong. So you will get this. Okay, this I get. There is another beautiful explanation for that I just found out some say maybe some 2 weeks ago. I just found out a different way to look at it. That is this one. Please tell T2's inequality, T2's lemma. I want anyone to offer that. How do you write it? T2, yes, please tell.
A square by x.
Correct.
Plus b square by y plus c square by z greater than equal to a plus b plus c whole square by x plus y plus z.
Good enough. So it means, see, we are all psychological people. When we are told that say some theorem, AM, GM, we will always write AM on the left-hand side and GM on the right-hand side. Similarly, here we will write this way, or Cauchy-Schwarz. But often, what happens, just like it is very much evident in trigo, when you're doing trigo problems, then you see you must have the ability to move from left to right, and similarly for right to left also. Means when you see 3 sine theta minus 4 sine cube theta, your mind should tell you it is sine 3 theta. And conversely also, converse is simple. Okay, so this of course is simple because we do a lot of time. Now here, this ability you must develop, this ability. Looking from here, this ability you must develop. This one means if you see somewhere this kind of thing, a plus b plus c whole square over x plus y plus z sometime, this one, then you should quickly say that, okay, this is nothing but a square over x, b square, this takes some practice, and c over j, because you are not accustomed to it. You are accustomed to writing this way, so you would not see it. Okay, so this is this. Now look hard at this question, this one. Denominator, now this is greater than equal to, don't worry. If I turn it around, means I will play with this one, the reciprocal of this first expression. So I will write, suppose I write 1 plus y plus g whole square, and over, I'll show you once, 1 plus xy plus xg, 1 plus xy plus xg. This is at least in the T2's reverse form. I'll say reverse form, something. This one, it resembles that one, this kind of thing, this one. So I've written purposely this way. This is less than or equal to 1 over 1. Good enough. Y square, so 1 square we write, y square over xy, and g square over xg. Done. Because I get 1 plus y over x and plus g over x. That is x plus y plus g over x. And the original thing was not this, but the opposite of it, the reciprocal of it. And so no problem. That was good enough because the sign I require is greater than equal to. So now sign also supports me. Direction of inequality is supporting me. So once I turn it upside down, I get 1 plus xy plus xg, and over 1 plus y plus g whole square. This is greater than or equal to x over x plus y plus g. I add them up. End of the story. Is it clear to you, this approach, second approach? That is faster.
Sir. Yes, sir.
It's faster. And in my experience, what happens that people are normally, that's why I asked the boy, I asked someone, and one of the students told that immediately this one. But you must be able to read this way also. You must have your eyes fixed on seeing both ways. That, okay, because sometime it will be there. I can give you many examples. In fact, short of time, so you can reach me out on my mail. I love to concoct and then keep track of these examples. So this kind of thing is there. Similarly, AMGM. So A plus B greater than equal to 2. This you will find many contests, many examples, good contests also, which will make use of AB over A plus B less than equal to A plus B over 4 in this form. Because normally when we see AB over A plus B, no, we are not reminded of this. We're reminded of maybe 1 by A by 1 by B, it more reasonably, or something else we think of. We don't think of this. So wherever you think this kind of thing, so try to look at it both left to right and right to left. You will be really pleased to find that, okay, you have improved a lot. Okay, so now
Sir, can you please repeat what you have just written?
Yeah, this one. This is, you know.
No, sir, this unequal.
This one, no. Okay, I'm writing in. AB over A plus B less than equal to A plus B over 4.
Okay, sir. Thank you.
So my point was just this. That's why I just wrote very casually. My point was that, of course, we are much used to seeing A plus B whole square greater than equal to 4AB. So half our life we are thinking of this only. And so when this present itself, we think that we more likely, if you think AB over A plus B, if we spot it, you are thinking of it as 1 by over 1 by B, and thinking that, okay, how to relate now this to some GM or something A plus B, how to relate that, you are thinking more. So this does not come into thought. So whenever you read some inequalities in this way, in your examples or some sort of examples or anywhere, then please keep track of them. Keep your eye out open for them, wide eye, that okay, this is something important, and tell your mind that it must go into your mind. You see, it is like in psychology they say that your mind is just like a guard, right? It remembers what it is told to remember. So you have to give instruction to it that please remember it, or please keep it in mind. Then it will be alert. The next time you need it, it will prompt that. Just like Zin appears in stories, Arabic stories, they will prompt, yes, what do you want, my lord? And you will say, yes, this I want. They'll give you. Okay, so let me quickly solve just one problem now. Can you pick the problem of like 10, 11, 12, 13? One of the functional equations.
So can you show them?
Yeah, I really, I'm looking at my master copy, so hard copy, so I'll show you. But I have shared it with HBCs, they will see you. They will give you 10, 11, 12, 13.
13 looks good.
Okay, so 13. See,
13.
Okay, I'm solving 10 and 13 both. 10 is very easy. It will take you just 5 minutes. 13 also 7 minutes, something like that, maybe. But both are useful. And why I have given them together? Because what you apply in 10, you will find that 13 wants a different strategy, but they are continuation. In fact, when I teach my classes, I always do 10 and then 13, I of course do without fail. Because okay, so 10 is I have taken 10 from Bijay Venkatachala book. It's a good book, I told you, all right, 10. But I will give two solutions, one my own also. Yeah, Bijay Venkatachala, VJV, very famous.
Sir also taught us in the previous class.
He taught me also. I was also at INMOTC 91. Many of you might not have been born at that time. So he taught me also, and then I started as a colleague at INMOTC. Okay, so say it's a good book. Motivation is there. So I will, and this example also came in this kind of thing, Australian Olympiad also, that I have checked. So f of, normally I'm checking all the Olympiads as a hobby. X minus y whole squared is x square minus 2y fx plus fy whole square. This is there. And see, I want all f r to r. I will, those who are doing for the first time also, they will really benefit from it, because it is something which gets unaddressed. So these two examples, 10 and 13.
Sir, we cannot hear you.
So there's a lag.